Hello everyone, thank you for joining me for today's presentation on a critical topic in cybersecurity, supply chain vulnerabilities. As we increasingly rely on third-party software and open source components, understanding and mitigating these vulnerabilities has become essential to protecting our systems and data. Our supply chains now include countless third-party services, vendors, and open source libraries that we rely on to keep our system functional and efficient. However, this same interconnectedness opens up potential points of entry for attackers. Let's see an example of the Kasaya attack 2021. Hackers used the vulnerability in a vendor software to breach more than 1,500 organizations worldwide. This incident alone demonstrated how a single vulnerability can compromise an entire ecosystem, highlighting the need for comprehensive security practices across all supply chain components. On my slide, I have also given a link which you can see to read more about this attack, and I will be like copying these links in the description of this video so that you guys can go ahead and read it if you want. Moving ahead, the open source software is foundational in many technology stacks today due to its flexibility, cost saving, and collaborative nature. However, this accessibility also makes it a prime target for attackers. Unlike proprietary software, open source component may lack consistent security oversight, which allows vulnerability to go unnoticed and potentially affect hundreds of applications. Let's see a classic example, which is the heartbleed bug in OpenSSL. This flaw exposed sensitive data information from password to credit card numbers and affected major organizations globally. Without rigorous security check, vulnerabilities like these can quickly spread across ecosystems and compromise numerous business and individuals. One of the most significant chain attack in recent history is the SolarWinds breach. So this is also a case study. So what has happened here that attackers compromised the SolarWinds Orion software update, embedding a backdoor that affected critical systems across US government agencies and major corporations. This case underscores the risks associated with the software update from trusted vendors. Even a routine update can introduce several vulnerabilities if attackers manage to slip through. It's a reminder of how crucial it is to secure our software supply chain from vendor selection to update verification. Another major risk area in supply chain is the prevalence of vulnerabilities in widely used libraries. A recent and impactful example is the Log4Shell vulnerability in the popular Log4j library, which is used in thousands of applications across various industries. This vulnerability put large companies on a high alert, prompting emergency patches and affecting organizations globally. This incident taught us that even trusted, widely used libraries require regular monitoring and security evaluation to prevent similar crises in the future. So let's see some of the best practices for mitigating supply chain risks. First is to monitor dependency and library continuously. Tools like SNYK used by Red Hat can alert us to vulnerabilities in our dependencies to help prevent them from getting unnoticed. Second, conduct regular security audits. For example, IBM X-Force Red Team specializes in identifying security gaps for companies, ensuring that supply chain stay resilient. Third, adopt a zero trust security model like Google's BeyondCorp, which restricts access based on verification instead of relying solely on network perimeter defenses. By implementing these practices, we can significantly improve our supply chain security postures and reduce the risks associated with third-party software. Let's see some of the secure coding practices, which are a cornerstone in preventing vulnerabilities from entering our software. Incorporating security checks directly into the development lifecycle allows us to address issues before they reach production. Veracode is one of the platforms that enables secure coding practices. Used by companies like Dell, it integrates security testing into coding pipeline, helping developers detect and address vulnerabilities early on. This proactive approach minimizes the risk of unintentional vulnerabilities and reduces the impact on the supply chain. Now, as we look to the future, we must also consider emerging threats like AI-driven attacks. G- Generative AI tools are enabling attackers to create new malware variant and enhance phishing techniques, making them harder to detect. For instance, CrowdStrike has documented AI-enhanced malware such as Emotet that can adjust its pattern to evade detection. As AI technology evolves, it's critical that we stay ahead of the game with detection and response tool to counterattack these increasingly sophisticated threats. So, in conclusion, securing our digital supply chain is essential to protecting today's interconnected ecosystem. By implementing best practices like zero trust models, secure coding, dependency monitoring, and regular audits, we can safeguard against vulnerabilities in our third party and open source software. Microsoft, for example, has adopted a stringent approach to supply chain security, closely monitoring vendors and dependencies to mitigate risk. Securing our supply chain requires a collaborative effort across all levels of an organization. And by taking action today, we help ensure a more secure tomorrow. Thank you for watching this video.